Let's look at an application of our right triangle inverse trigonometry. Many modern aircraft have wings that are swept back, meaning that the wings angle backwards instead of extending straight outwards from a perpendicular direction from the fuselage or the body of the plane. The front edge of the wing on a Boeing 747 jumbo jet is about 47 meters long. If the wingtip, so the end of the wing, is 27 meters from the side of the plane, from the body of the plane, what is the angle of that backward sweep of the wings? So in this illustration we have sort of the top-down view of an airplane of the Boeing 747. And again, notice that the wings are not extending perpendicular out. The front of the wings do not stick straight out from the plane. They kind of angle backwards. And so in this problem, we want to figure out how much of an angle are they angled backwards. So if you looked at, there's kind of this line extending outwards that we've drawn perpendicular to the plane, kind of right at the front of the wings. And we want to figure out the angle theta between that perpendicular distance out from the side of the plane to the actual front edge of the wing. Okay, so that's the angle theta that we're trying to find. So to kind of set this up, let's think about drawing some triangles here, and then we can think about our right triangle trig. So we know that the body of the plane is kind of would be one side of the triangle, and we do not know its length, but we do know sort of the distance from the plane. And distances, heights here are always perpendicular, so we know that distance, that other side of the right triangle is 27 meters. And the wing would correspond to sort of the hypotenuse of our right triangle, and that is 47 meters. And again, we want to find not the angle inside the triangle, but we want to find this angle theta out front of the wing, outside of the triangle. And so we have this right triangle. One of the legs is 27 meters, the hypotenuse is 47 meters, and we're trying to find the acute angle outside of one of those triangle angles inside the triangle. So we could go ahead and find the angle that is next to theta, and theta and that angle would be complementary, so they'd add up to 90 degrees. Or we could think about taking this rectangle and that perpendicular side and completing them. You're using them to complete a rectangle. And if we do that, we don't know the length of the top of this rectangle, but we do know that that length on the top has to be parallel to the body of the plane. And so the other side of this rectangle also has to be 27 meters. So instead of looking at the triangle formed by the wing of the plane and then the fuselage, the body of the plane, we can look at the triangle that's kind of just out in the space in front of the wing. Okay, and it is still a right triangle. Okay. But now we're trying to find the angle theta that's inside this triangle, and its adjacent side is 27 meters, and the hypotenuse is 47 meters. So how would we go about finding that angle theta? So as I just said, we have the adjacent side is 27 and the hypotenuse is 47. So we could almost think of setting up, a right triangle equation here. We have the cosine of theta is equal to the length of the adjacent side over the hypotenuse, right? And we know the adjacent side, so cosine of theta would be the length of the adjacent side, which is 27 meters. The length of the hypotenuse is 47 meters. So we have cosine of theta equals 27 over 47. And we're trying to find the angle to that. And so if we want to flip the inputs and the outputs, so here the input is theta, and the output is that fraction, 27/47, then that's going to convert from a normal cosine function to the inverse cosine function. So let's rewrite this as theta is equal to the inverse cosine of 27 over 47. Okay. 27 over 47 isn't really one of our nice unit circle values, like a half or root 3 over 2. And so we're going to have to compute this, we're going to need to use technology. And so we want to go ahead and compute the inverse cosine of 27 over 47 using a calculator or some other technology. And we want to compute this. I didn't specify this in the problem, but let's go ahead and compute this in degrees. So make sure your calculator is in degree mode. And if we compute that, we get that theta has to be, or will be, 54.94 degrees. So that means that the wing is swept backwards. So from perpendicular, it is swept backwards almost 55 degrees, 59.94 degrees.